we need to obtain the square root of our complex number negative 1 plus iota. So let's begin. First, we will consider complex number z, which will equals to negative 1 plus iota. Our task will be to convert this given complex number to its polar form. For that, we'll need the value of r and the argument. So r can be simply calculated by taking the square root, and within the square root we will add the square of the real part and the imaginary part. So that's going to give us the value square root of 2. And the argument of the complex number, which is theta, that's defined as the inverse tangent of the real part or the imaginary part, which is positive 1, divided by the imaginary part, which is negative 1. Now this is tangent inverse of negative. So in place of 1 we can have tangent of pi over 4, because we know the tangent of pi over 4, that's equals to negative 1. Now negative tangent of pi over 4, this can be also expressed as tangent of pi minus pi over 4. So let me write it down. So here we're using the fact that tangent of pi minus 4, so this is simply equals to negative tangent of pi over 4, which means we have tangent inverse of tangent of 3 pi over 4, which gives us 3 pi over 4. So we have obtained the argument of a complex number as well. Now we can replace, we can represent our given complex number in the polar form as z, given by square root of 2 multiplied to cosine of the argument theta, which is 3 pi over 4, plus iota times sine 3 pi over 4. Now we're going to use the fact that cosine is sine a periodic function, and that simply means that cosine of 3 pi over 4, this can be also expressed as cosine of 2 pi m plus pi over 4. Similarly, our sine is also a periodic function, so sine 3 pi over 4, this can be also expressed as sine 2 pi m plus 3 pi over 4. So here m will be taking integer values, so values of m will be 0, 1, 2, and this continues. Now we will rewrite our complex number. So we have z given by, so let's write square root of 2 in its exponent form is 2 raised to the power of 1/2 multiplied to cosine. So instead of 3 pi by 4, we will have 2 pi m plus pi over 4 plus iota times sine 2 pi m plus pi over 4. Next, we will take the nth root of a complex number. So that means we are raising the complex number to the power of 1 over n, which gives us 2 raised to the power of 1 over 2n whole multiplied to cosine of 2 pi m plus pi over 4 plus this is 3 pi over 4. I made a mistake here, 3 pi over 4. So we have 3 pi over 4, 3 pi over 4 plus iota times, this is also 3 pi over 4, sine 2 pi m plus 3 pi over 4 whole raised to the power of 1 over n. Now this expression, we can apply the De Moivre's theorem. De Moivre's theorem simply states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of some number n, that is simply equals to cosine of n theta plus iota times sine of n theta. Fine. So this gives us 2 raised to the power of 1 over 2n. Now we will multiply 1 over n to the argument of cosine and sine, which is going to give us cosine of 2 pi m divided by n plus 3 pi over 4n plus iota times sine 2 pi m divided by n plus 3 pi over 4n. Now we have our complex number. This is the general root of a complex number, or the nth root of a complex number. We originally had negative 1 plus iota, which was represented by the complex number n. So its nth power will be given by, or the nth root will be given by 2 raised to the power of 1 over 2n whole multiplied to cosine of 2 pi m over n plus 3 pi over 4n plus iota times sine 2 pi m over n plus 3 pi over 4n. Now here Since we have to find out the square root of negative 1 plus iota, so the negative square root of 1 plus iota is simply negative 1 plus iota whole raised to the power of 1 half, which means that our n value is equals to 2. That means we can rewrite our given expression as negative 1 plus iota whole raised to the power of 1 half equals to 2 raised to the power of 1 over 4 multiplied to cosine of, so we have 2 pi m divided by n, so this is simply m pi, plus 3 pi divided by 4 times 2 is 8, plus iota times sine m pi plus 3 pi over 8. Now the next task will be, since this is a square root, so a square root we know there will be two distinct roots. For that we can take two values of m, so m could be either 0 or it could be 1. So we'll take the first case when m value is equals to 0. This means that negative 1 plus iota whole raised to the power of half, or the square root of negative 1 plus iota, that will be 2 raised to the power of 1/4 multiplied to cosine of, so 0 times pi is 0, so we have 3 pi over 8 plus iota times sine 3 pi over 8. So this is going to be one of the root of a square root and the other one is going to be equals to, so we will take m value to be equals to 1, such that we have negative 1 plus iota raised to the power of half equals to 2 raised to the power of 1/4 whole multiplied to cosine of, so in place of m we have pi, so we have pi plus 3 pi over 8, so this is 11 pi over 8 plus iota times sine 11 pi over 8. So these are going to be the two square roots of our given complex number negative 1 plus iota.